Hello, this is the user's guide about thyristors. With the thyristor model, I can simulate the change in the fire angle. Under the diode, there are two thyristors. The model of these two thyristors is exactly the same, no difference, it's just a flipped graphics. So you can drag and drop a thyristor, you can rotate it by right click, you can double click to access the input form. The thyristor can be triggered only in the positive half cycle of the voltage across the thyristor, and it can conduct current as long as the current is positive. If instead of a resistor only I add also an inductance, you can see that the current continues to flow after the voltage zero of the source. We can increase the time the current continues to flow after voltage zero if we increase the value of the inductor. Let's now have a closer look at the thyristor input mask. First you have to input the base frequency you are interested in. This is in our case 50 Hz. However, this is not needed in case you're choosing a reference. A reference is, for example, another voltage source, and then the frequency is just taken from this other voltage source. The offset angle here will be discussed later. Here is the fire angle, this is really the trigger angle, and this goes from 0 to 180 degrees in the positive half cycle of the voltage. There are two ways how I can change the fire angle. It's either by the slider here, or I can go directly into this one. You see this is exactly the slider value, so I can change it here, and then you will see that it has also changed here, right? So this is now 60 degrees. The stay on value is seldom used. This is especially used when, for example, when you trigger the thyristor, there could be a transient current, and this transient current would have an early current zero, and then the thyristor would clear again. But you don't want that, so therefore you safeguard the thyristor for clearing during a certain time. And this is what you can adjust here. As I said, it's seldom used. Let's talk about this reference now. When you drag and drop the thyristor first, it will be an autoreference. That means that the reference voltage then is its own voltage over the thyristor. But normally you prefer to have the voltage reference of a voltage source, because this is much softer, it's cleaner, whereas the voltage over the thyristor can be bumpy, and therefore if you want to choose a reference, you go here and then you just pin the reference, and then you see from now on the reference for the trigger angle is not anymore the thyristor itself, it is the reference voltage, and then also this frequency is not relevant anymore, it's not needed anymore. So this will be what you do most of the cases. And if you change the phase angle of the reference, you also see that at the same time this triggering point changes as well. Now it's time to address this offset angle. The offset angle is a fixed angle which can be added to the variable fire angle. The offset angle can be used if you have, for example, two thyristors but using the same reference. One of the thyristors should always fire on the positive and the other thyristor on the negative half cycle of the common reference voltage. To make the case for the offset, here is an application example. This is a thyristor bridge, and I would like to have this voltage source as a reference for all the four thyristors. So I go to the individual thyristors and select the reference. I do it for all. So now all the four thyristors build a reference to the same source. But what we want is that these two thyristors trigger on the negative half cycle, whereas these two thyristors trigger on the positive half cycle. So I go to these two thyristors and add an offset angle of 180 degrees, each one of them. So this is not true for this one, and I go to this one, and also here I want to have 180 degrees. Okay, let's now run it and see what happens. So at least the fire angle is 0 for all. But what I can also see now is that if I change the fire angle of one thyristor, is only happening at one thyristor. But I would like to be able to trigger all the 4 thyristors at the same point in time. And therefore I need to build a group. All the thyristors which belong to the same group can be controlled by one slider. So I would like to group all these 4 thyristors so that I can control them by one slider. To build a group of thyristors, I go to the menu bar and there thyristors group, and then I get this small window, and now I build a new group and I group these 4 thyristors all together in one group. If I have more thyristors, I could build more groups, and each individual groups would then be controlled separately but by one common slider for each group. So let's now run it and let's see what happens. So you remember I could control only one thyristor, but now I can control all thyristors together. And this is exactly what we wanted to see. I can also go and expand a little bit the view so that you get more cycles. Let's go to 400 to keep the overview. So you see, so now all the sliders are always at the same fire angle. See, so I can just choose one of the sliders and they will control all the 4 at the same time. If I want, I can ungroup the thyristors. Again, I go to thyristor group and then I highlight group 1 and I can see which thyristors are belonging to this one group, and now I can delete it or I can leave it as it is. Be careful if you now change the network topology or you delete one of the elements. It's very likely that the group will be destroyed and that the reference will be destroyed. You remember we had references of the thyristors, so the reference will also be destroyed, most probably. So you have to rebuild the references and rebuild the groups. And remember, we said that there is a delay of these 2 thyristors. Yes, this delay is important, otherwise you cannot control them on the same reference. In this case, without the delay angle, the result will be nil, because all the thyristors will just trigger on the positive half cycle, and therefore the arrangement will not work properly. It will support your understanding if you try it yourself on www.ecsp.ch. Thank you, bye.